I'm Guillermo Melantoni. I am product line manager for the 1-3D line. And yeah, I mean, we are in an interesting moment in time. It's like some sort of perfect storm, right? In which we have a lot of changes, as Aubrey was saying, from, imagine, right? I mean, before Industrial Revolution, craftsman and apprentice, then mass production. Then at some point, people started to identify that they had to get segments for the products. Imagine cars, right? On the 20s, whatever. For every car is the same, right? Afterwards is different models for different segments. And now, thinking about customization, how can people make things their own, right? So between the changes on the mechanism of distribution of digital stuff, right? Imagine YouTube. Imagine what we can do on 3D, and with this amazing things here, the 3D printers, and all those things are very important. But there's another aspect, which is technology and the software behind it, right? So anytime you think about technology, you can talk about this process in which things are first impossible. Hey, I cannot 3D print anything, right? Then, well, I can, but it's super. It's really expensive. It's difficult. Then it becomes possible. Then it's almost required. Hey, do you have a 3D printer? And at some point it's, hey, how can you not have a 3D printer, right? We are kind of there right now, right? And it's actually a nice moment to be here because you are ahead of the curve, right? So what I'd like to show you now is a couple of things, a couple of tips to show you how you can actually be ahead of the curve as entrepreneurs and working with a vast ecosystem of people that will actually change the world somehow. So one thing about technology, right? And I want to talk about very fast about 5 trends. And as Aubrey was saying, at Autodesk, we are very well known for our professional things, right? 3ds Max, Maya, AutoCAD, Inventor, Revit, you name it, 157 products. But there are big trends that we are trying to see how we can take all that technology from an elite, or from a very expensive application, to something that can be consumed by people that don't have the training and don't have the resources to buy a $25,000 mold flow, for example, for simulation of a mold. Right, so we have identified a couple of trends, for example, on reality capture, right? What does that mean? Not all of you guys know how to model 3D, right? But many of you would like to capture something. In this case, for professionals, 3D scanning has been around for a while, right? So you can get a 3D scanner at a big cost, create a point cloud of a building in this case, and start to do some sort of reverse engineering from there to do whatever you need. Now, who has a 3D scanner at home? Not me. If you have one, just tell me. I want to use it. But we all have phones, right? And with a phone, with an app that costs $0, like 1-3D Catch, you can actually create a small mesh and point cloud, actually, of anything. I mean, could be this guy's kid, could be any object, right? So after that, after you have the object, you only need to heal it if there's any gaps. You need to clean it up if there's anything there that you don't need. And all of that can be done directly with an app that works on an iPhone or an iPad, and then going into the product on web-based or desktop-based. You can do that sort of healing that will allow you, for example, to make a 3D print of the object, right? So from I will never be able to model this guy, because why would I into that, it's a second. Or for example, getting any model, and instead of 3D printing, slicing and cutting cardboard, look at this. I mean, this was science fiction a couple of years ago, right? Now it's totally possible. Going back from the impossible to the possible and required. Cloud data. What does that mean, right? I mean, we hear a lot about cloud. I mean, that's one of the hype words of the last 2 or 3 years. But right now, people can do this kind of complex. In this case, this is AC and air conditioning and some other infrastructure for a building that's done by many people, sometimes in many different parts of the world with many different applications, but just converging into a model on the cloud, right? But now, I mean, how many people will do that? Not many. I'll just kind of get crazy there. But you may know about Google Docs, right? In which many people all can also work on the same objects. Or for example, a new product we released called 1-2-3 Circuits, in which many people can actually work on the design of a board. Or Minecraft, right? Anybody has played Minecraft ever? Yeah, you're my buddy. Good. Yeah, Okay, so for example, we have applications that work completely on the cloud. Tinkercad is one of them. I just attended 2 trainings or two classes on Tinkercad for 6, 7, and 8-year-olds, right? So at that time, I don't remember what I was doing at 7 or 8. I was not doing this. I mean, there were no computers at the time either. But anyways, the whole point is that this is completely cloud-based. So there's a lot of technology, a lot of computers doing stuff. You can have collaboration doing so. For example, you can have many people working on the same file, eventually a whole class. The point is that things are changing rapidly, and the only way to keep it up is understand what's happening and have the clarity to understand what's the business model, how can I also do something that gives me some revenue on top of this, right? So all of these processes are very simple. Again, they're cloud-based. They enable collaboration, and they're at the base of some of the applications we are offering right now. So again, from professionals to consumers. Infinite computation. How many people have this amount of computers at home? Probably just you, right? Hopefully. No, actually, you wish you wouldn't, because you have to maintain all this crap, right? So if you think about that, and if you think about how people are doing this kind of rendering, so that kind of rendering, that she's a render, right? It's incredible. Now, 10 years ago, or maybe 5 years ago, that was basically done by very, very specific experts.
Wait, that's not a picture?
No, that's a rendering. A very obsessed guy probably did that. And it's probably a 3D print somewhere. But the point is that this is home styler. This is something that I use at home, that my wife uses at home, right? In which I can just put some furniture, take a picture of a room, put some furniture, and then get this quality of image, right? This was something that was done by people that were having a business. I used to render for food, which was my job maybe 8, 10 years ago, right? Doing this kind of images. That it was just me and 5, 6, 7, 8 people more. And now this is available for the masses. Again, going back from an elite to everybody. The same with simulation, right? I mean, this is created by an application that costs a lot of money, that tells you how the air flows in a room for a surgery, right? So this is the right way for the air to flow, and you can actually see how things get better. But now, this is again something done by experts and with very expensive software. But we have the code, we have the IP at Autodesk, so what can we do with something like this? Maybe show you how some pieces of a 3D print will break, right? Because you'll see the 3D printers in action, and they will talk about 3D printing. At some point, you also realize that some things are not printable, and you want to know that beforehand. If not, you're going to print something that's going to break or it's not going to print well, because what you want to create is, and so everything red there is telling me that something is going to be wrong, so I had to fix it beforehand, because I want to do something like this. And at the end, I want to produce something like this, right, which is printed in brass, right? But I don't want to do 50 prints in brass in order to get to the right thing, because each of them is $150, right? So again, simulation going down to the masses. And the same is happening with 3D printing. So when I'm talking about from digital to analog, I'm basically talking about the workflow from a digital model that you may have got in Catch based on photographs, or you may have just modeled from Tinkercad or anywhere else. Could be any products. I don't care right now. And what you do then is you can take it into 3D printers, which is basically additive manufacturing, because you're adding material to something that's been building. Subtractive if you're going into some sort of milling, right? And some other forms of assemblies that are pretty relevant right now for this conversation. But the point is that we have many materials, and the complexity is free. How would you ever build that thing by hand, right? It's kind of hard. It's almost impossible, right? So on 3D printing, since the guy's only just putting material where it's installed on a layer, right? They don't know that this is complex, right? They just do it, right? Just like a 2D printer. The difference between printing a text or printing the Final Supper is nothing, right? It's just ink going to certain pixels, right? So that is that's interesting. So you can do many parts and materials. You can make rigid and flexible prints all at the same time, depending, of course, on the kind of printer you have, not on these ones in particular right now. Textures and shadows. You can print opaque and transparent materials together. So you can actually build very interesting prototypes or actually products based on this, which is where I come back to that revolution, right? Which is that if right now, right, when you want to take something into production, how do you do it? I mean, do you want to take this to China and get a mold and start fabrication? How many parts do you need to make that profitable, right? Is it really even feasible? Now, if you have a product line of 10, 15, 100 things, you can actually do it. I mean, probably I can sell this thing, right? But I would not sure I would be going to mass production because I don't know how can I ensure the volume that gets me there, right? So that alone is a very big change that you guys need to understand and to see how to make it profitable. Because this is happening everywhere. It's happening in architecture, in industrial design. This is, I mean, and then at a more experimental level, there are experiments about printing houses, so printing with concrete, right? Or printing with biological materials, so in this case, for medical purposes. Or printing at zero gravity, right? Because if you are at the ISS station up there and something breaks, you don't have ACE very close, right? So you really want to be able to fix it up there. So many things are changing. I mean, something like this, which is just a prosthetic hand that can be printed in $20, right? As opposed to getting a real prosthesis probably for a couple thousand. And this is the right example.
Yeah. Since you can print organs and everything, can you print food?
Can somebody answer that later? Yeah, I've seen printing chocolates and doing stuff with meat.
Yeah, they're printing food now, chocolates. They're printing pizza, like splicing together DNA now.
Yes.
There's a company in South San Francisco that has extruders for, you know, A, G, T, C.
Right. The point is that this is changing business models of firms that were totally clear what they were doing, and all of a sudden they get disrupted by somebody that just puts for free on Thingiverse the parts to make a prosthetic hand, right? So those things you have to think about. And again, there could be many examples which I don't have time for now for that. But basically, this revolution that was happening again, starting from kind of high-end printers, is now also there, right? You have 3 of them there. Can you see that one? It's up there, right? And some others that are around, like the replicator, the cube, and stuff like that. So these things are going into people's desks right now, as we speak. Right? So the other piece of the puzzle is, okay, what's the software? I mean, how do we work with this? I mean, yeah, we have the printer, we have the business model changing, we have the revolution. So how do I jump into this? Right? So in our case, we offer a whole family of products. In this case, we call it the 123D family. 123D is kind of the brand for everything. Take a look at this, for example. Do you like to make this kind of characters, right? So you can basically start modeling a skeleton, sculpting, and adding textures, and all these things could be ending up on a render or actually being 3D printed very easily, printed both in color, in this case, or just in plastic, right? So that was, again, before just guys doing something in Maya for the movies, as Aubrey showed, and now can be done by any of us. Mesh mixer. You got a mesh from somewhere. The mesh is kind of the 3D format, the topology of every 3D model is kind of based on triangles, and we can get any 3D model here, and we can make any kind of changes to it. Some of them pretty funny, right? We can remesh things, so we can change the definition. We can also add support materials, so the printers know exactly how to work. We can do pretty crazy stuff with this, right? And very fast in this case. Actually, this thing was made with Mesh Mixer. This was just a 3D model of a school, right? That then, by a similar process to this, and then some putting a stencil on top, I got to this result, right? So now those tools are up there because there are a lot of models up there, right? And you can also leverage all these. It's not that you have to model a rabbit. You can actually get something from somewhere. 1-3 design, and this is probably, I need to run it, right? So I got this sculpture from Catch. I take it into 1-3 design. I just want to make a table for that object. Maybe I also want to 3D print the object, but I also want to make design the table that's going to be there. So for example, in this case, I'm just adding a couple of objects here that I will convert into the base of a table, right? And I'm putting the thing on top so I can see how it works. I'll just start working with the supports and just again defining the materials, because maybe this thing is not going to be 3D printed, but it's going to go into a wood shop, and I want the whole thing to be clear for the woodworker. I'm just adding some curves there to make it look prettier, right? And then I'll just make a copy and put it on top. There you go. All of a sudden, I realize that I want some more detail there, some more bling, and I just want to add this thing at the bottom and just make 4 of those. And this is pretty much the speed at what this would work for somebody with some experience. But there you go, right? So now you have a table, you have this. The table could go to a woodworker and just have some documentation, and the other thing you printed. Voila, right? From pictures of an object to the object itself. Like music, I have this Strat, right? The body of a Strat. So I want to take it into a shop. In this case, where I just want it in cardboard for my son, because if not, he's going to destroy it. But I now also want it for me. So I want to send this to not additive manufacturing, but subtractive, so something that can carve it and mill it. And in this case, this software will create the toolpath so the drill can come and do all this shape, right? And then I can also see how it's going to look like. So this is the simulation of the machine. And when I was talking about simulation, this is exactly what I'm talking about. I know the model, but there I need to know how it's going to work in real life. So this is just telling me how this is going to be carved on the piece of wood, because I really want to make sure that piece of wood is not wasted, right? And several workflows from any kind of piece of art, just taking that into 3D printing. So calculating the amount of support material, understanding how much it's going to take me to print that thing, how many can I fit on the bed of the printer. All those things are things that I need to take care of. And it's not just about, again, it's not just about the hardware, it's about where you get the things, which is the software that supports all the creativity that you have. Because at the end, it's not that we're all designers, but we're all creative, and we're just trying to give you tools that will make you more creative, and also understand which are the business models that are underlying all this, which are part of this big revolution that it's definitely changing the way production happens. So if you're actually even interested in how some things like this are working, somebody else may have already documented things, like the guys from Instructables, which is also one of our groups, in which you can take, I mean, from textiles to food to anything 3D print to electronics, you can get some idea of what's happening. Because the other good thing is that this is a great community. The community of DIY is really, really helping each other a lot. So you can actually get a lot of help on many things you want to do if you go to places like Instructables. And basically, that was it. I mean, it had to be fast, but I just wanted to make sure that you understood the trends, that you understood how some of the products that we have are supporting those trends, and how interesting is all this in order to think about what are the business models coming next. So I think that I'll just pass it to you then. So thank you very much for your attention.